I'm Esther.
And I'm Sean.
I write about AI news here at Tech Target in Massachusetts.
And I edit Esther's stories.
We're here to talk with tech experts about everything AI and ChatGPT.
Don't forget Google Gemini.
Whether it's who's ahead in the generative AI race, the metaverse, digital twins, or even the latest in autonomous vehicles, we've got it covered. Right, Sean?
Yep, we've got it covered.
Welcome to another Targeting AI podcast, everyone. Sean and I are back, and this time we are speaking about a very timely topic. We're here with Dr. Gary McGraw, co-founder of the Berryville Institute of Machine Learning, a think tank for AI and machine learning security. He has 8 best-selling books on software security and also used to write for Tech Target a while ago, which is so cool. Most recently, his think tank released new research about the serious risk associated with large language models. Thank you so much for joining us, Dr. Gary.
It's my pleasure to be here. Thanks for having me on.
All right. Hey, Gary. So to kick it off, in your research, you're talking about black box foundation model risks. You identify 23 critical risks with large language models. Can you kind of start by saying where this whole concept of the black box comes from originally? And what are the most critical risks associated with black box foundation?
We're the guys who decided to call it a black box. So in 2020, we published a risk analysis of generic machine learning models, all of them, that was designed around a 9-component generic machine learning model, kind of a process model, so to speak. And what we did with the new work is we adjusted those results that had recognized 78 risks to the LLM case. And what we found out was when we started looking at each of the 9 components, 4 of them were hidden from the user. The user of an LLM buys a black box or rents a black box from somebody like OpenAI or Google or Anthropic or Microsoft or Meta. There are a few of these foundation models. And the interesting thing is those components that are in the black box involve a number of risks that we have identified in the past, 23 in particular. And decisions about how to manage those particular risks are left up to the vendor. That is, the user doesn't even know about the risks or get to decide what to do about them. Those decisions are made. When you rent or buy a foundation model, that's what you get. You get those risk management decisions made for you. I hope that makes sense.
It does make sense. Very interesting. I do wonder though, like what causes these black box risks, right? Because you're saying that the user doesn't know about it. So is it caused by the creators, by the creators not performing their due diligence? And then are there ways to avoid these risks?
Well, look, so let's define what risk means. A risk is not an error or a mistake. A risk is a design aspect that could go awry if it were improperly managed. For example, here's a risk. The risk is you have to build an enormous large language model, and by enormous, I mean like trillions of parameters. Where do you get enough data to do that? Well, it turns out that you have to scrape the entire internet almost to get 14 trillion data points to build one of these large language models. So inside of that scrape are a lot of horrible things. And the risk is that in your scrape, you manage to scrape up stuff from 4chan and all sorts of other terrible places, and also things that are just plain wrong that are posted on the internet. As you know, everyone on the internet is not only a dog, but they're also wrong. And so all of those data get imported, and that's the sort of risk that we're talking about.
Can you identify some of what you are actually put in your research though? Do you mind?
Absolutely. Let me give you a laundry list of the top 10. How about that? Number 1,
Sounds
and
good.
then we can talk about any of these that you want to. Number 1 is recursive pollution. Number 2 is data debt. Number 3 is improper use. Number 4 is black box opacity. Number 5 is prompt manipulation. Number 6 is poison in the data. Number 7 is reproducibility economics. Number 8 is data ownership. Number 9 is model trustworthiness. And number 10 is encoding integrity. So as you see, these are some risks that need to be thought about while you're building your LLM application so that you don't put your business, your enterprise, at more risk than you want to take on when you adopt this technology for yourself. Remember, we're talking about risks in machine learning that are built in.
Can you zero in on prompt manipulation? How does that work?
So, prompt manipulation is unfortunately the risk that's taking up most of the oxygen in the room. If you remember adversarial examples from, vision-based AI systems, the ultimate bottom line is we're talking about malicious input that a user is putting into one of these systems. Here's what we say about prompt manipulation in our report. Prompt manipulation is to LLMs as adversarial input is to machine learning vision systems. That is, prompt manipulation is really a type of malicious input risk. But even without malicious intent, prompt manipulation can lead to unstable behavior. Don't forget that when using the same prompt, LLMs can already sometimes produce wildly different responses. This is due to their intentional stochastic design.
I just want to talk about go back to LLMs. Your research is focused now on LLMs. So, what about small language models or smaller ones or proprietary ones?
But
In-house ones are getting a reputation of being just a lot safer and carrying fewer risks. Is that true? Completely true.
it
But also,
depends on how they're built.
are the risks also smaller with open source models or closed source models as well?
All right, so let's address that. Open source versus closed source is a non-issue. That doesn't really matter. The source code of the model is neither here nor there. What really matters is the data set used to train the model. So open source models don't give you the entire data set. You have to go out and get it yourself. That is a false flag and a red herring that people are talking about that is misleading and unhelpful as a distinction. Now, can you build a small language model? Why, certainly you can. We've known about those for years. For example, Llama and BERT started out pretty small, even though they were things that were built by Google. And what happened is when OpenAI built ChatGPT, GPT-3, they used a bigger data set than anybody had ever used before. And the LLM started behaving differently. That is, it started being more conversational. The predictions that it was making about which word to use next were surprising and delightful. And some people have been misled into believing that LLM, a large language model, is able to pass a naive version of the Turing test. That is absolutely ridiculous. But what you have to understand is that all of these language models, large or small, are really auto associative predictive generators. And so the question is, what are you auto associating over? What is your initial training data set? And that's the difference between a big language model and a small language model, generally speaking, although there are also less nodes in the network. But the biggest difference is just the size of the data set used for initial training. I want to say one further thing, Sean, because it's an important thing. When people build, quote, their own language model, what they're often doing, in fact, 99% of the time, is they're taking a foundation model that's already developed and they're training it a little bit further with their own proprietary prompting and some other maybe human driven, non associative feedback learning. And so those further steps do not eradicate the risks that are built into the black box. In fact, all they do is hide them even further. So it is not the case that these language models that are built by organizations on top of the big public LLMs are any more secure because they have the same black box in the middle.
That's very interesting. Before I touch on that point, so what you're basically saying is it doesn't really matter whether you're using your own data or you're using data that's scraped all around the web, we still have the same risk associated.
Well, no, I'm not saying that. Here's the
Okay.
deal. You can't build a large language model yourself unless you have an unbelievable amount of data. The data set is 14 trillion data points. I don't know how to explain how big that is, other than that human beings are extremely bad at numbers that large. The only organizations that have managed to scrape up that huge amount of data are big, giant tech companies like Microsoft, OpenAI, Anthropic, Google. You can't just go out and build a data set very easily that's that large. There are two reasons for that. The main reason is that the original data sets for the large language model foundation models were created by the big tech companies who were trading their data piles with each other. So Meta let got to use the Google search data. Google got to use Meta's stuff. X/Twitter got to use, everybody was trading their data piles. Lately, these companies have decided to keep their data piles to themselves. And it's not clear that we have enough data that hasn't been segregated in that way, what I call data feudalism, which is the notion of, hoarding your data and not letting other people use it. So building your own LLM foundation model that's as powerful as the ones that are available commercially is really very hard. That's one thing, the data. Number two is it cost $100 million to build a large language model, foundation model. It's not free. In fact, it's not even cheap. And one of the risks that we worry about is that scientists and computer scientists in particular don't have the budget to build a real large language model, so they have to build a small one. Now, are the risks the same? No, they're not the same, but neither's the behavior. So the idea that you can train up an LLM on your own data is really driven by a misunderstanding of how much data that takes and how much money it costs to do the initial training off. That's why everybody is using foundation models, 99%. I hope that clarifies that a little. It's a really good question, Esther, and it's a confusion that a lot of people have about this technology.
No, it definitely does. I was wondering if we can go back to prompt engineering or prompt manipulation engineering for a
Yeah.
second,
Yep.
because I found it interesting because, like you said, the large language models, the like ChatGPT, they do give different answers, even if you're asking the same question, right? And I think that we're seeing with like lawsuits like the New York Times, where they recently mentioned something. We put in a prompt and it regurgitated our articles or whatnot.
Yep.
Is there a way to kind of curb that risk of like producing bad answers, even though you're asking the same question?
Excellent question. The answer is no, because of the way the foundation models work. These models are so large that they do a lot of memorization. And the associations are so strong that when you put in the first 8 words of an article of the New York Times, it's going to pull the rest of it up out of its memory. But I want you to really grasp this one thing about LLMs. They don't understand anything. A large language model takes a pile of text as a prompt that you give it, and it predicts what the next word is going to be. And it produces that next word a few times until it's done, and that's its utterance. All it is an auto associative predictive generator of words. That is, there's no understanding there. It's just a whole big pile of data that was driven by some understanding because people created it that we used a machine to model. So, and I'm saying this not as just a random guy, but as a guy with a PhD in cognitive science who's been an AI guy since 1995. I was one of Doug Hofstadter's students at Indiana University, the guy who wrote Gödel Escher Bach, and I wrote a pretty famous AI program myself back when I was a kid. And then I did software security and wrote all those books in a different field. And then I retired and came back to AI. And now I'm going, well, what progress have we really made? And the answer is we've made a lot of progress because of more computer cycles and bigger data piles, but we've made very little progress in cognitive modeling, in general AI, in anything but what some people call stochastic parrots. And it's important not to forget that. So these things don't know anything, they just produce very interesting text.
I love that. So I should ask you also, but I have to ask this question. I feel like you're saying that you're not in the camp of AI is going to take over the world and we
Not
should be
yet. AI could take over the world, but not in its current instantiation, right? We should be concerned about things like the singularity, but we're no closer to that now than we were 20 years ago. And the idea that a stochastic parrot or a large language model of the sort that we have today, these auto associative predictive generators, will somehow miraculously solve the general AI problem is wrong. We haven't made progress on that front at all. Now, there are some people who believe that you could use a large language model to pass the Turing test. And I don't want to get into the particulars of what exactly that means, but those people are treating the Turing test incorrectly. And they don't understand what the judge of a Turing test ought to be like. These auto associative predictive generators that we built, they do surprising and really cool and fun stuff, and we should continue to play with them, but we don't have the concerns of taking over the world. Now, let me tell you what concerns we do have that are very real. These things can produce text about anything, and they're really good at copying text that's in their training set. Now, imagine that you trained up a black box foundation model like GPT-4 on input that included conspiracy theories, alternative facts, things that are just completely wrong, and it learned to associate those things. Now, if you ask a system like that to produce a new conspiracy theory, it's going to produce one that's powerful because the ones that it learned were powerful, even though they were wrong. Nothing that is training an LLM is teaching it to be right or wrong. It's just teaching it to associate words in a pile in a bag with other words in a bag. That is a dangerous thing. So if we can create deep fakes, new terrible conspiracy theories, racist content, misogynist content, all biased content, false facts, things that don't exist, using this technology, we need some way of controlling the output so that it doesn't get back out there into the world and just cause more confusion among people who don't know which way is up.
Okay, can I
Will
ask?
that impact
Yeah.
elections coming up? It sure will.
Well, let's get back to elections, but I just want to ask you. Like, seems like a lot of the risks you're talking about are social risks, safety risks, morality risks. What about cybersecurity? What about just
So, Sean, those risks are directly tied to cybersecurity. The way we got to those risks and drove them out of this system is by thinking about security engineering from a build security in perspective. If you've heard the term build security in, I'm the guy who made that term up. And we have not done any building security into this LLM technology. Instead, we just built a very powerful technology and we're setting it loose on the world without thinking about what those risks are. Those risks are directly tied to technical aspects. For example, where'd you get that initial training set? What was in it? That's not a society risk. That's a technical risk. If we could just train up an LLM with real science and real facts and build an associative pile that way, that'd be a powerful thing. But there's not enough of that data in the world to do that yet. So we have to include the garbage. Now, that is a technical problem. Now, could we make artificial data and train it on artificial facts? Sure, we could. But, these machine learning models are really good at finding pretend data that we're trying to use to train them up and modeling that in a way that we understand is incorrect. Another way of putting that is we're building this technical thing, and the technical problems in the very design lead to all sorts of risks that are very much real. And that's what our reporting is about. Are they relevant to security? Yeah, they are security risks. Believe me, I'm a security engineer. That's what I did my whole life.
okay? What about the opposite? What about using generative AI to protect data data and systems from attack?
That's a really good question, and yes, there is potential there. I don't like to talk about it too much because that confuses people then about the difference between the security of machine learning and using machine learning for security. But let me give you an example of using machine learning for security. The other day, in a private discussion list of a bunch of security people, we were talking about the problem of reporting, where large language models are being used to just create fake articles. They will read an article that a real reporter like Esther writes, and then they'll produce a copy. They take the idea and they produce some content that's just kind of a copy. Now, this is a huge problem for journalism, and the question is, how can you spot that sort of thing? And actually, one of the companies that I advise called Redshift is in has built some technology to look around for websites that are spoof websites that, for example, pretend to be Bank of America, but they're really not. And we can use machine learning technology to discover those things using analysis of DNS records and cryptography and all sorts of other technical aspects, not just the text. But then looking at things like logos and all that stuff, it turns out machine learning is pretty good at spotting those things, and so Redshift has made some progress with that technology. That's an example of using this sort of generative AI for good, and there's plenty of room for that.
I really like the idea that you're talking about, which is like it's all technical, right? Because I feel like with the popularity of ChatGPT, with the popularity of GPT and stuff like that, we feel kind of like emotionally tied to it. And so being able to like differentiate of like this is just a technical
Beautiful.
technology that's producing technical result is so interesting. I don't think I've heard that.
Esther, I got to tell you something. Here's a story from when I was born. There was a guy named Feigenbaum, and he wrote a program in 1966 called ELIZA. ELIZA was an AI program that just used keyword matching to pretend to be a therapist. So somebody would talk to it. A user would say, "Hey, I'm here to talk about my mom," and it'd say, "Oh, interesting. I like talking about people's mothers. Tell me more about your mom." And that it would do this kind of Rogerian therapy prompting and listening. But all it was keyword matching and spouting out kind of canned questions to pull things out of the user. People believed that this program, Eliza, was a real therapist. And they began to think about it as a person they were having a conversation with. In 1966, when the technology was rough and it was obvious that it was just a program. That's called the Eliza effect. We've known about the Eliza effect in AI since 1966, the year that I was born. So 57 years, almost 58. And that's that has not gone away. So if you feel like you're having a conversation with a person when you're talking with an LLM, that is a very normal human reaction to this technology. It is also incredibly wrong.
I feel like you just broke a lot of people's heart there, Dr.
I'm
Gary.
so sorry. It sucks. You still don't have any friends, guys.
But I wanted to talk a little bit about bad debt because I found data debt because you talked about the fact that the reason this issue is so technical is because systems like ChatGPT, GPT are scraping all the data from the internet. And so I wonder, I still come back to the same question I asked before. Is there anything these creators can do? Because
Yeah.
we also have, especially when it comes to data, we recently spoke with a data labeling company, Sama, who goes to look for those toxic data. And
Uh-huh.
so is that a way to kind of go and get rid of that data depth or whatever it is?
Well, it would be a way, but it's very expensive and it would take a really long time for people to clean up the data. 14 trillion is really, 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 really big. And if you had to look at each association, it would take you longer than there is time in the universe as a human being to do. Now we can write some programs to try to do that, but we just haven't figured out a way to do it. Believe me, if the tech companies were able to do that easily, it'd already be done. and it is not an easy task to clean up the ocean. How do you clean the ocean, is what you're asking. And I want you to think about that really. We have a dirty ocean on this planet. How do we clean the ocean? Oh, damn, that's hard. That's the size we're talking about. Now, I do want to say one thing that I think is important for a lot of people to understand. Why do we have machine learning? Well, let's see. We've known how to program computers for years and years and years, since the very beginning, since the 40s. And when we know how to do a task, we just write a program to do that task in a series of steps. That's a program. When we don't know how to do something, but we have a big pile of what that we would like to model, we can use the big pile of what to train a machine to become the what. Remember, we don't know how, so we have a huge pile of what. We use the what to train a machine. The machine learns to be the what, and it does the what, but we still don't know how. That is where we are with machine learning.
All right. Going back to the foundation models and the creators of these, and who's going to make OpenAI and Anthropic and Google? Who's going to make them be more responsible and build safety into these foundation models?
Outstanding question. I really do not like the answer to this, but I think that, and my group thinks that LLMs need to be regulated. And we don't think that the use of LLMs needs to be regulated. We think that the building of LLM black box foundation models needs to be regulated. So, what OpenAI is building, what Meta is building, what Google's building, what the Chinese are building, we need to think very carefully about those black box foundation models, what goes into them, and so on. So, the government regulation is sadly, and I'm not much of a government guy, our only recourse. The real question I have as a modern citizen of planet Earth is, are governments big enough to control huge multinational corporations or not? The answer these days is beginning to be or not. Our chance now is to regulate these foundation models right now. And we have in our report on page 21, there are a number of risks associated with the black box, and we have really particular technical suggestions about what shape that regulation should take.
You say just the LLMs, right? And I understand it, because it's like you have to deal with the issue at the root. However, people are going to do bad things. People are going to use, like, we're going to talk about the election pretty soon, but people are going to do bad things with whatever you give it to. Like, there's a good use for anything, can be used for bad or evil. It's just
Yep,
it
that's
can.
right. That's right.
So why not the use of the LLMs or the use of these systems
We
themselves?
can build better LLMs. We can build LLMs that are safer, that are more reliable, that are more trustworthy. We know how to do that. The only way to make companies do that is to regulate them so that they do that.
But you said government is perhaps not strong enough to do that. Who then would do it other than government?
Nobody. Then we're in trouble.
And what about the criticism? There's a guy. You ever see the X account? Beth Bezos, the spoof Jeff Bezos account.
No,
That's a guy.
because I got off of Twitter when Musk bought it because I
Okay, well,
don't
this guy is a computer scientist who leads this sort of like accelerationist movement. He feels that
right.
if government regulates too much, then government will AI will become less accessible to people because it will leave the power of AI in the hands of the biggest tech companies and regulate them and prevent other tech companies from reaching up there. So, do you give any credence to that?
Sure, I do give some credence to that. But let me just ask you a philosophical question. If we build a system by modeling the way society has been so far, and the auto associator creates content that keeps the status quo the way it ought to be, are we doing a good thing or a bad thing? You're a guy in power, it sure sounds like a good thing. So, as a sort of quasi elderly, elder statesman, gray beard, white tech guy, I should be one of those people saying, yeah, let's let AI take over the world. But I am not, because I believe that we need to have a progressive society that does more to build things that are tools for everyone and not just for the elite. And I
Would
think
you
in this day of late stage capitalism, we have to do that.
would you do it the way that it was suggested in the executive order? With the LLMs would have to be reviewed by NIST or
That's a
cumbersome?
great question, John.
Yeah.
That worries the heck out of me because NIST is confused about LLMs. They think that you can understand the black box by probing it from the outside with prompts. They think that we can have white hat hackers prompt an AI and then we can clean it up ex post facto. We cannot do that. It is not possible to do that. We have got to build better foundation models. We cannot test our way out of this problem. And NIST is completely confused about that. I'm sorry to say, because they're doing good work piling up the attacks, but they're not doing good security engineering work at all. So if the executive order just says, have everybody at DEF CON security test these things and we'll fix them, then the executive order is confused about what we need to do to clean up this problem or this potential problem. And I think the real answer, and the reason I'm doing the work that I'm doing as a retired guy right now, who has, I could sit around on a beach for the rest of my life. But the reason I'm working on this is because I think it's an important problem. And I think if we're going to do this security engineering right, we need a hardcore, deep risk analysis of this stuff. And so that's what we did.
I wonder though, you have been in this field for so long, right? And so and I've been told that regulation always comes really, really, really
I
late,
know, and I
right?
don't believe in regulation too, so I can't believe I'm saying that. You guys have no idea how counter this is to my own personality. But I
Is
honestly
there
think
no
that's all we
hope?
can do.
It feels like you're saying there's no hope, right? It feels like we are living in a pessimistic world, and kind of like leading to the election right now. We have this problem. We have the huge, like, I guess we're talking about robocalls, we're talking about AI deepfakes, and so like we don't have the regulation, and the U.S. election is not the only one. Obviously, there are countless of elections this year, and so like there's no solution is basically what you're saying, right? For
Well,
the
I
2024.
think the solution is that we need to be pretty cognizant of how this technology that we've built can be misused. Now, I heard what you said before about everything can be misused, and as a guy who's actually used his shoe to hammer in a nail, I know exactly what you're talking about. And humans are really great at that sort of thing. So we can use this technology for good and for bad, but we need to be very, very careful about this election because of that. And I think we all know what the risks are. I mean, you've seen the robo stuff already. The deep fakes are really very good, and the populace is really incredibly naive. And so, we sort of bumble around as a species, taking advantage of science that most people think is magic, and not thinking about the risks that are brought along when we build a new kind of technology like we've done now. And so, I mean, we can't just quit. We can't turn all the machines off. We can't like stop using electricity. I'm not suggesting that, but I am suggesting that we need to proceed with some caution in this election cycle. And it's something that I think we need to be very vocal about. And we need people to understand how this tech works, and we need to understand what's likely to happen so that people can take a skeptical view. And I'm optimistic that that will prevail. So the world is just filled with such naivete.
I also kind of wonder, right? Because I've been trying to put together an AI election story, and one of the things the person that I spoke to recently said, well, it really doesn't matter because a lot of times people already have their decisions, right? They already made the decision of who they're going to vote for. And so just having like an AI robocall is either going to push them towards their decision, but it's not going to shift them away from their decision. Do you
That's
agree with that?
wrong. That's wrong. That guy is wrong. So make that guy go read about Cambridge Analytica and understand what happened with micro targeting. in previous elections.
With the election, underway, with deep fakes now possible at scale for anyone to do
And
audio,
conspiracy.
video. Yeah. So what to do about it? How is it? How do we stamp it out? The executive order did speak to it. Who's going to regulate it? Russia's not going to regulate it. China's not going to regulate it. We haven't taken any steps to regulate it other than have the FBI go after a couple of people.
Yeah, I think we're going to have to let it ride. But I think that we should let it ride with our eyes open. And that's all that I'm asking. Now, I want to end on a sort of a positive note. Look, I was very excited when I was 16 years old and my parents got me an Apple II Plus in 1981 for Christmas. And it changed my life, the rest of my life. I still have that computer sitting on the stairs. I was so excited about that Apple II. And I have to tell you, I have not been as excited about technology as then until these large language models started doing what they're doing. It's exciting. It's amazing. It's fun. They don't understand anything, but that doesn't matter from a cognitive science perspective. It's still an incredibly powerful tool. And we're just at the very beginning of that ride. So, we can be optimists and we can say, well, we've managed to bumble our way past things like, I don't know, nuclear proliferation and some other things that were sort of species threatening so far, a few world wars. So maybe we can get past this just fine. Maybe we'll do fine. And that's the way I got to look at this. But that doesn't mean that risks don't exist. That means that we need to acknowledge them and try to address them as best we can as we continue to move forward with this new tech.
Okay, well, thanks. We'll call you Dr. Gary. Thanks, Dr. Gary. And to our listeners, please check out Berryville Institute.
Let me give you the URL. It's berryvilleiml.com.
Thanks to our listeners, and please go on to Apple Podcasts and leave a review, share on all your social media platforms. We'll see you next time on the Targeting AI podcast. Thanks again, Gary.
My pleasure. Thanks, Sean and Esther. I appreciate it.
Thank you. This was great.